So our next problem is find whether the number is power of 2 or not. Okay, so let's take an example. So what is the first power of 2? 2 to the power 0 will be 1, 2 to the power 1 will be 2, 2 to the power 2 will be 4, 2 to the power 3 will be 8. So these are power of 2. Okay, and remember 0 is not a power of 2. Okay, 0 is not a power of 2. Now, what can be a basic approach? So my basic approach is, what if I keep dividing the number? Okay, what if I keep checking the remainder and dividing the number? So let's say if we have 15, first take mod 2. Okay, so why I'm taking mod 2? Because if it is a power of 2, it cannot be odd. So anytime you find an odd number, it will not be a power of 2, we will directly return. So 15 mod 2, 15 mod 2 will be nothing but 1. Okay, so it is odd. We can directly return 0. 0 means it is not a power of 2. Okay, now if it is even, let's say 6. 6 is even, but is it a power of 2? No, right? So first check even. So 6 mod 2, it is 0, right? If it is 0, just divide it by 2. So 6 divided by 2, it will be 3. So our number will be 3. Okay, again do the same thing. 3 mod 2, 3 mod 2, it will be nothing but 1. Okay, so again remainder came as 1. As soon as remainder came as 1, return false, return false. Okay, so what we are doing, we are keep on checking, whether my remainder is 0 or 1. Okay, so anytime, if it is a power of 2, the remainder will be every time 0. Let's take 8. So if you do, let's write it step by step. Let's take 8. 8 mod 2 will be 0. So do 8 divided by 2. Number will be 4. Again, 4 mod 2 is 0. So again, divide your number by 2. Your number will be 2. Again, do 2 mod 2. It will be 0. So again, divide your number. Your number is 2. 2 divided by 2. It will be 1. Okay. So as soon as you reaches 1, it means that your number is a power of 2. Okay, your number is a power of 2. Why? Because see, any number, let's say 8. 8. If you break it, it will be 2 into 2 into 2. So first time you divide by 2, second time you divide by 2, third time you divide by 2, at the end you will get 1. Okay, at the end you will get 1. But if it is odd, so it will be 9 divided by 2. Here itself it will give you remainder as 1. Okay, so if remainder is 1, it is not a power of 2. It is odd. Odd number cannot be a power of 2. Okay, even if it is even. So if you take 10, let's say 10. So 10 divided by 2, it will give you 5. Okay, 5. If you do 5 divided by 2, it will give you remainder as 1. Which means anywhere, see, if it is not a power of 2, anywhere you will get a remainder as 1. So this is my first approach. Okay, what can be my second approach? So second approach. Okay, just remember this algorithm. Brian-Kernighan's algorithm. Please remember this. Brian-Kernighan's algorithm. Okay, what does it says? It says that if you take n and n minus 1, okay, it will clear the rightmost side bit. Clear the rightmost side bit. Okay, how we can use this algorithm here? Let's see. So if it is a power of 2, listen carefully. If it is a power of 2, if a number is a power of 2, we will definitely have only one single set bit. We will definitely have one set bit. Only one set bit. Only one set bit. How? Let's see. So we write it as 1, 2, 4, 8, 16, 32. Right? What is 2 raised to power 0? 1. This is 1. What is 2 raised to power 1? It is 2. What is 2 raised to power 2? It is 4. What is 2 is to the power 3? It is 8. What is 2 is to the power 4? It is 16. So every time it will be 1, 2, 4, 8, 16, 32, 64. Okay, 128, something like this. So there will be no power of 2 in between these numbers. There is no power of 2 in between these numbers. Okay, so any combination of these numbers will not make a power of 2. Okay, for a power of 2, and only we will have only one set bit. We have only one set bit. Okay, so that's why we can use Kernighan's algorithm. Why? Because we have only one set bit. We have only one set bit if it is a power of 2. If it is a power of 2. Okay, now if we have only one set bit, let's say 8. In 8 we have only one set bit, 1000. And if I use Kernighan's algorithm, what it will do? 8 and 7. So 8 can be written as 1000 and 7 can be written as 0111. So if it is a power of 2, your answer will be always 0. If it is a power of 2, your answer will be always 0 by using Brian Kernighan's algorithm. Why? Because we had only one set bit, and Kernighan's algorithm says that it will clear the rightmost set bit. So if it is clear the rightmost set bit, the answer will always be 0. Okay. If we have only one set bit and you will clear it, the answer will be always 0. And if it is 0, we can say that it is a power of 2. Okay, Brian Kernighan's algorithm is very important. A lot of time you will use it. There's a lot of applications of Brian Kernighan's algorithms. Okay, so now if you take some number which is even but not power of 2. So if you take 10, let's say 10, 10 can be written as 1010, right? Okay, now if you do and with 9, 9 can be written as, this will be 8, this will be 100, right? This will be 9. Now if you do end of this, if you do end of this will be 0, this will be 0, this will be 0, this will be 1. Okay, so it will be non-zero number. And if it is non-zero, it means that it is not a power of 2. Okay, so power of 2 is very important. This problem is very important. Okay, we'll use the concept of power of 2 to find power of 4, power of 8, power of 16, power of 32, any number, okay, above this power of 2. So if you want to find the power of 2, you can use this. Okay, you can use Kernighan's algorithm. That is the optimist one. So I hope you understood this problem. Okay, what we can do? We can use Kernighan's algorithm. Just write it somewhere, Kernighan's algorithm. Okay, and time and space complexity. So see, we are doing only one operation. So it will take order of one time only. Okay, we are just taking one operation, one AND operation. And by using this, by using our previous approach, it can take till log n times. Okay, because we are doing every time we are dividing by 2. Okay, so it will take log n times in worst case. Okay, time and space complexity is easy to calculate in bit manipulation. So if it is going beyond log n, that means you are doing something wrong. If it is going beyond log n, you are doing something wrong. Okay, now let's move forward to next problem.